to Mathematical Minutes with Dr. Rhonda Fitzgerald, where we strive to give you understanding to mathematical concepts in minutes. So today we'll talk about even and odd functions. As you see here, our definition for an even function is f of negative x is equal to f of x. So that is, once I evaluate my function at negative x, but I get out the original function. The definition of an odd function is f of negative x is equal to negative f of x. So once I evaluate my function at negative x, I actually get the opposite of the original function. So let's look at how to algebraically test for even and odd functions. So let's look at our first example. The first example that we want to look at is the equation f of x equals x cubed minus x. So that's x cubed minus x. And just like in function notation, the very first thing I want to do is find my f blank, or f blank notation. So that just says put a parentheses, a blank set of parentheses, wherever you see x. So that'd be blank to the third power minus blank, right? So we replaced all of our x's with blank sets of parentheses. Next, my very next step in determining if something's even and odd is finding f of negative x. So I need to calculate f of negative x. So here we want to actually calculate f of negative x. So all this says is to plug in a negative x in our parentheses. So negative x to the third power minus negative x. So in this particular case, now we just want to simplify this. So let's simplify this. Let's think about this. Negative x to the third power. So a negative raised to an odd number remains negative. So this simply gives us negative x to the third power. Negative times a negative turns positive. So this becomes positive x. So f of negative x is the value negative x cubed plus x. And what I like to do is let's compare this to my original function. So this is my value, and I want to compare this guy to my original function. Let's compare these. Let's look. In my original function, my x cubed was positive, but down here it's negative. Here my x was negative, but this guy is positive. So if you notice, this really means that f of negative x ended up being the opposite of the original function, right? Each sign flipped. Each sign from the original function flipped. So this tells me that they're exact opposites. And when they're exact opposites, we see that this is an odd function. So this guy is odd. So that's my first example. Our first step was to find our f blank, calculate f of negative x, and then compare it to the original function. So let's look at another example really quickly. Let's look at another example for our even and odd functions. And so in this particular equation, we want to look at if I have x squared plus 1. So I want to find f of x is equal to x squared plus 1. And we want to determine if this is even and odd. First step, find our f blank, blank squared plus 1. Then from here, our next step is to find f of negative x. Negative x squared plus 1. Now simplify. A negative raised to an even power turns positive. All right, so this becomes x squared plus 1. So now we see that our f of negative x is equal to x squared plus 1. And here's the step where we want to compare what we calculated to the original function. And when we compare these two functions, we notice they're exactly the same. They're exactly the same. So this is the case for an even function. When I evaluated f of negative x, I ended up with my original function. So this function is an even function. An even function when they're exactly the same. The very last and quick and simple last example that we want to look at is the example of what if I had f of x is equal to x cubed minus 1. So once again, f blank, blank cubed minus 1. Find our f of negative x, which would be negative x to the third power minus 1. Simplify this. This becomes negative x to the third power minus 1. Now we want to compare to the original function. And when we compare this to the original function, we see that the x's, that the signs change for my x cubed. And the original was positive x cubed. At the bottom, it's a negative x cubed. However, we both have negative 1 and negative 1. So this stayed the same. So let's look at this again. This changed, but this stayed the same. There's no rule for half and half. There's no rule for half even, half odd. So when it's not, if it's not even and it's not odd, this case, it would be neither. So we've seen the three examples, one of even, one of an odd function, and one of neither. So this is how we algebraically test to see if a function is even, odd, or neither. Thank you.